and thanks for having me, Adam. Yeah, so I'm the structural engineering director at Structurecraft in Seattle. So I lead the Seattle office. But for the past 16, 17 years, I was working at Magnus and Clemensic Associates in Seattle. So as a consulting engineer, I worked primarily in the cultural group. So I did performing arts buildings, museums, civic buildings. I learned a ton working there. It's a world-class engineering company and world-class people, and the leadership there is incredible. And then I started getting into timber. One of my first projects was the Lincoln Park Zoo Pavilion that I did with Studio Gang. Has these triply curved glulam beams, and it sort of opened my eyes to the world of timber and the possibilities. That was over 10 years ago. And then that led to us getting these, what we're calling T3 projects, right, with Hines mass timber office buildings. And I got to work on the Minneapolis T3 one. And during that project, I met Lucas at Structurecraft, and we kept in touch. And as I started getting more and more into timber, I realized it was, a growing passion for me. And then last year, it's amazing, it's only been a year, because I've learned so much, that I decided to make the switch, given the opportunity to open the Seattle office for them. So,
yeah, interesting that Hines is doing their first timber office building right now in Melbourne as well, a 10-story office building. So it's exciting to have them coming into Australia. So
yeah, they've been key with pushing this movement, which is great. So
yeah, that's it. We always need those few developers ready to push the limits. And for them here, it is a 10-story office tower, which I don't know what it's like in your part of the world at the moment, but 10 stories is still pushing the limits, I feel like.
Yeah, no, it's great to see that.
Well, I was in my bit of research in Structurecraft, I was also seeing that you engineer and builder. Is that right? So you do. So your
Correct.
company. So why does this combination of engineer and installer make sense? Because this combination, doesn't happen everywhere, and it's probably uncommon to what traditional construction is.
Yeah, no, that's a great question, and I talked a little bit about this during my Master Builder Mindset down the Mass Timber Conference. And the example I use there is, because I've worked with all materials, steel, concrete, is if you walk in a steel building and you see a beam column joint, it's a gravity connection. 90% of the time, it's a shear tab with bolted. It's a bolted connection, and maybe that's probably covered up, maybe not. But if it doesn't fit, you can weld it. But when you're looking at mass timber beam column joint, for example, there are literally dozens of ways to make that connection. And a lot of times the success of the project really hinges on what you might do for that connection. And what I've learned at Structurecraft is that we've been constantly evolving how we do these connections, because we get real-time feedback from our guys on site to say, this was a pain. Don't ever do this again. And then we pivot and start looking at a different option. And so what I realized, and I realized this during my consulting career, is mass timber is really set up for that. What's actually an old school concept of this master builder, where the engineer really understands that the design that they're drawing, how that works in the actual site. How long does it take to erect that? What extra material costs are you putting into your design that you might be able to take out, because fiber cost is a big component of the overall cost. And so I think that's really been the mindset that we've had, and it makes sense with the projects and the experience that we've had, to have that blend between the engineer and builder.
This question might be getting a bit in the weeds, so you don't have to go into it. But what has say for a beam column connection, what sort of connections do make the most sense in terms of efficiencies, and have you landed on? Because being such a young industry, there is, especially for large scale projects, it is a huge cost is how you handle those junctions. And
Yep.
If you get it in the most efficient way, then it's it's a huge thing to pass on.
Yeah, I mean, these connections, going back to that steel example, if they don't fit up, you can't just easily fix them and have the architect be happy, right? So you have to have the tolerances in place, but also there's different aesthetics that may or may not be a driver. I mean, a very simple solution is you can notch the column and just set the beam on, and away you go, and still have a positive connection. But of course, if you have fire rating, then there's a lot of really interesting research being done and testing on these connections that really don't have much steel at all. They're just these CNC notches. They fit together. And so they sort of have this natural fire protection. Or we've had examples on projects where we want to set the beam down, but you actually don't want to see the notch where the beam hits the column. You want the column to sort of bypass, which involves trying to study, okay, well, then do you do 2-story columns or 1-story columns, and how does that impact your overall column width to make sure you have enough meat on the column to run it by the beam once you notch it through. So those are some of the methods that we're seeing out there.
We've spoken a little bit about how the engineer's role is changing for, in combining with the installer. In what other ways is the engineer's role changing? I guess with off-site construction being a new trend as well, particularly with timber buildings.
Yeah, so with that engineer build mentality, I feel like the engineer's role is changing to understand more of what is actually buildable, and also what designs actually create the fastest erection. Because one of the big benefits, as we know about mass timber construction, is that you can erect it quickly. Well, there's definitely cases and decisions you might make that will slow it down. And that can mean real dollars, right? Say you have multiple buildings on a site, that can add up to a significant amount of time and costs. And so I think that's what we're seeing. And I'm a little biased because I work for an engineer builder, but I feel like if you don't have that knowledge, then you sort of hit a ceiling in terms of how much you can actually detail these structures, because you just don't know the downstream impacts to the construction site. And so I think that's sort of where I feel like the engineer's role is morphing.
You mentioned before around tolerances being important to design that properly so everything can move really fast. Is there any other things that engineers can get right to really aid that speed in construction? Because as you said, if we're always compared against traditional construction, and our biggest point of difference is that speed, I mean, it is a really important thing to maximize as much as possible.
Yeah, and it's also related to the other systems that you might choose for the building, right? I mean, it's important, obviously, as an engineer, a structural engineer, to thinking about things holistically, right? And so say you have a tower and you're looking at lateral systems, you might have a concrete core option, you might have a brace frame, perimeter brace frame option. And if you have the concrete core, now you have to weave in how you erect the timber behind the core and dance around. We had this issue with Minneapolis T3 of dancing the timber with the concrete core moving up. And then actually the next project, Atlanta T3, had a perimeter brace frame that could be erected at the same time as the timber. So I think that there's that component that's coming into play for the engineers to understand that there's not just the connections, right? We're not just talking about the beam column connections. It's a holistic sort of system and how it interplays with the lateral, the foundations, etc. So.
New skills that are really relevant to engineers, particularly if there's people starting out their career or looking for a career change, that they can add to their toolbox to move into this space.
Yeah, I mean, I think the two big ones, well, there's three actually. One of them is just detailing and the ways that Europe and Canada have been doing the detailing. I mean, really, Europe and Canada have a head start in the mass timber world versus the United States, and so understanding the differences between these types of screws that are possible, right, and these different glued-in connections, and the relative cost differences between these is really key to understand and develop that skill. Also, we see a lot of demand with our higher end architectural designs for parametric modeling and understanding that we need to be nimble and finding efficient solutions by quickly looking at different configurations of a truss, for example, for a long spanning. And then also, because fire is a combustible material, I think the skills for engineer related to fire are really important. When I was in the consulting world, I was working a lot on just type 1 buildings. I didn't even think about it, right? You got steel and concrete, you're good. You need to fireproof things. Here, you have all these different nuances in the code versus if you're type 4 and all the different type 4A, B, C, or if you're type 5A, or these different construction types and how those impact the decisions you make as an engineer. So those are the 3 big skills I see.
Yeah, and under that fire one, you mentioned like understanding the code as well. So we got the actual fire engineering, understanding the fire behavior, but then also navigating the code. Do you think, because if that isn't known properly, then compliance can be a bit of a risk, don't you think, on some projects?
Absolutely. And a lot of times these buildings, especially in seismic zones, will be probably peer reviewed as we go taller and taller. So really understanding those aspects, because you're going to be scrutinized, no doubt, by the building department, likely. So
the things that comes up a lot on this podcast for successful projects is the importance of collaboration and trust, particularly like you're speaking about the multidisciplinary approach and understanding that you really need at the start of projects. So what do you see as the importance of this, and what is the best approach to maximizing this on projects?
Yeah, I think that's a great question, because, and I personally have experience with this. When I was a consultant, a lot of times we look at these timber buildings as options, right? The architect would say, hey, can you design this out of steel, concrete, and timber? And then the timber would be sort of thrown over the fence and people would try to price it. And inherently, there's this sort of fear factor, for lack of a better word. And then there's this cost is just naturally higher than it really needs to be. And so one of the advantages that we try to educate our clients is, if we're actually building it, we know real time the cost impact, so that you don't go into CDs and all of a sudden say, hey, time out, timber prices are gone up. We have to do a round of value engineering. And now all of a sudden we have to revisit the schedule of when we can get on site. And that's an impact to the owner. And so what we try to do is then alleviate the risk that would normally be on the owner and say, we'll lock in the cost. We understand the timber market. We understand where we can get the timber. We watch how the timber goes up and down, and we'll manage that ourselves. And then when you're making a decision with the architect or the owner to say, oh, we're going to do this connection, and they are on board and they decide it, then there's a level of trust that that's not going to be revisited down the road, because you are actually the one on the hook to procure and install that. And so then when you have that early collaboration, there's that feeling, that vibe in the room, that when you make that decision, you don't have to revisit it, like I said. And I think that's huge for this market when we're all super busy. I mean, it's fantastic that the mass timber industry is booming, but there's downsides to that, right? And it puts a lot of pressure on a lot of projects. And so I think that's one way really maximize that trust during that collaboration process.
Makes a lot of sense. And there is a ricochet effect, like what you're in your part of the world, having a high demand there. For Australia, it means there's more European supply into the US and North America, and it does ricochet, and then the demand of all suppliers goes up, and prices have been fluctuating recently. So it's interesting that if you're putting your own skin in the game, that would be attractive for clients and head contractors, I'd imagine, where you take the share of the wins, but also a share of the risk as well.
Yeah, exactly. I mean, it's a stressful process, and I'm learning that, right? But with Structurecraft's been in business for over 20 years, and they've learned lessons the hard way, right? I mean, like any business that you with those projects and how that process went with the cost mitigation, you get better and better at it. And so and that's key. And obviously with timber, we want to tell it's sustainable, and we want to get local materials if we can, but sometimes you have to cast the net wider and in order to actually get the building built.
Absolutely. So what are getting now towards the end of the podcast, so maybe an open-ended question. So what are the other keys for successful timber design and construction? Some of the things we haven't really covered yet.
Yeah, this one I actually learned when I was working on Minneapolis T3 with MKA, was the importance of making sure that you have a route for MEP services. And it actually will dictate how you lay out your bays and your structure. And that was an eye-opening experience for me, because if you're designing in steel and concrete, you coordinate that, but usually you're in CDs, and then you're negotiating openings. But you can weld on shear tab, or stiffener plates on openings in the steel beam and make it work. You can't obviously do that very easily with timber. You can just pop a hole, nor do you want to, because the timber is exposed. So the architect wants a clean, thoughtfully laid out MEP system, most likely within the framework of the structure. So that's something that I think is key for any project, is right off the bat to sit down with mechanical, the architect, and the structural, and say, all right, what is the way we're going to get air distributed in this building? Do we have a raised floor? If you have a raised floor, obviously it makes it a little easier. If you don't, how are we going to access all the points in the floor plate? So we've done tricks where we've had shorter bays. This is what we did on Minneapolis. Shorter bays to create sort of highways, because if you have a short bay, you have a shorter beam, and tuck the ductwork there, and then you can access down the beam lines. Or maybe you have a purlin system and the girders are dropped, and so you can run the services over the girders. I mean, there's examples too. You can see like the Adidas building with precast and then holes in the precast. I mean, there's lots of different ways to do that, but I guarantee they've probably all been thought through very early in the process. And then, the other thing that I talked about, but are the details. If you're, designing with steel and concrete, you might do the details in CDs. And here with timber, you should do the details straight off the bat. Say you're notching the purlins at a girder, well, all of a sudden now your purlin size, if you dial it in to work perfectly, may not actually work well for the connections, and your connection costs will go up. So those are the things that are really pushed to the front of the design process with mass timber that are really key for success.
Well, there's some really great points and advice for everybody listening right now. It's been great speaking to you today. If people want to find out more about yourself and Structurecraft, where should they go?
Well, you can always reach out to me at ljohnson@structurecraft.com, but definitely go to our website. You can see our projects, and learn a lot there. And then there's obviously ways to get in touch with folks from there. So